All righty, folks. Good to see you all. We're going to keep going here a little bit. This is day 2 of our trig identities and trig proofs. So we're going to have just a little bit more fun here. But before we jump into the notes, I wanted to spend a quick little second here and just have you guys go through and review and try a couple trig proofs for me, just so I can see how we're doing here a little bit. So let me give you a couple. Tan squared theta times sine squared theta equals tangent squared theta minus sine squared theta. And you guys go ahead and start that one while I'm writing up the next one here. Secant theta 1 plus secant theta equals cosine theta minus 1 all over sine squared theta. All right. Go ahead and pause the video, guys, while you're finishing that one on the first one, the one on the left, and then we'll talk about it. All right, let's try that first one. Now, you could really go anywhere you want with it. For me personally, I would probably go with the right side just because I have a little bit more room to play with there. I can potentially maneuver it and manipulate it just a little bit more. So let's see how that works. So tan squared theta times sine squared theta. Well, the first thing I do, I see tan and I see sine. It's not really helping me out, the tangent. So I'd probably turn that one into sine squared cosine squared. Now, this whole thing is sine squared over 1. So what I would do is I would go ahead and I'd make it a common denominator. So I would have multiplied this side right here by cosine squared theta on the top and bottom. So that way I can put it together as one fraction. Anytime I got multiple fractions, I like to try to eventually get them together to become 1. So tangent squared theta, sine squared theta equals sine squared theta minus sine squared cosine squared theta all over cosine squared theta. So I'm working on that right side, and I'm looking for either some trig identities or algebra. So now I'm looking at that numerator, and I see that I have sine squared in that numerator. Both terms have sine squared. So I would have gone ahead and I would have factored out the whole thing. So if you are still using generic rectangles, that's fine. I would have just done right over here and gone for the factored out that sine squared out of the top. So if we factor it out, it would become sine squared times 1 minus cosine squared. And as we've seen before, 1 minus cosine squared, as soon as I see that cosine squared kind of sitting by itself, I start thinking of Pythagorean triples. And the one with the cosine is it's the most common one we use. Sine squared plus cosine squared equals 1. So that means sine squared is 1 minus cosine squared. So we'll do a real quick substitution one more time, a little trig substitution there. And again, it's either trig substitutions using Pythagorean identities or reciprocal identities, or the occasional sine and cosine, or we're just doing algebra. Lots of algebra. So 1 minus cosine squared would be sine squared. And we're just about done here, friends. So now at this point in time, I see the sine squared. Oh, drop the square here. See the sine squared right here. I'm trying to figure out how to make the tangent squares show up. I got 2 sine squares in my numerator, so I can break this up. So if I leave that pink sine squared kind of by itself and put the blue sine squared over the cosine squared, I can start to break them up just a little bit. So I got that other sine squared by itself. And just for the fun of it, to show you how it was broken up, it just came out over 1. So it's just kind of hanging out there. And we have tangent squared theta, sine squared theta, equals tangent squared theta. So here's our last trig substitution right here, sine squared over cosine squared. That is tangent. We did that trig substitution at the very beginning. We had to come back and hit it one more time at the end. And we're done with that one. So we'll go ahead and give ourselves, let everybody know that we are done. Or you can write a little QED if you want to. You bring out your Latin. All right, friends. If you haven't had a chance, now go ahead and pause this one and give it a shot. Well, I see cosine and sine on the right side. And even though I see a sine squared, I could go with that. However, I'll be honest, I see the secants here, and I kind of want to tackle those a little bit. I think I might be able to do a little bit more with those secants. Again, both will work. So I'm going to take these secants and turn them into cosine. Again, you could use any side you want to. It doesn't matter. This is one idea that I see. Again, you guys, one of the big things about these trig proofs, there's so many ways to do this, and it's one of the beautiful things that I love about it. So many ways. Just have fun with it, man. You can literally do anything. So I'm going to go ahead and multiply everything by that common denominator. So when I multiply by that common denominator, essentially all I'm multiplying by is 1. And I end up with 1 over cosine theta plus 1. So now, in English, we have context clues, where sometimes if you're trying to figure out the meaning of a word, and you don't know what it means, you kind of look at the context around it. Well, it's kind of the same thing also with trig proofs. So at this part here, it doesn't look like there's much going on, but I can look at the other side of the equation and try to figure out what I'm looking for. On the other side, I notice that I have that cosine theta minus 1 in my numerator. So if I want to make that cosine theta minus 1 show up in my numerator on my left side, I got to multiply top and bottom by it. I'm going to use the context clues of what I see on the right side to go ahead and make that show up on the left side. So notice down here, I'm going to multiply two binomials together. Cosine theta plus 1, cosine theta minus 1. So what all we have there is the difference of squares when I multiply it. So I have cosine theta minus 1. Well, I got my numerator all set up now. Now I just got to play with my denominator here. So that equals cosine theta minus 1. And again, I see my cosine here, so I'm going to go ahead and do a trig substitution there. So just like we had before, we've already done this one. It's right over here. Sine squared equals 1 minus cosine squared. So cosine squared minus 1. Oh, I got a little issue here with my signs, don't I? Okay. So that should probably be a cosine, not a cosine minus 1 for the beginning. Well, friends, we're going to keep going here. So we'll go ahead and do that anyways. Just to, so this is technically going to be a negative sign here that we end up with, because writing this problem, I took this problem from an old assignment. I probably should have checked it first. But anyway, this still kind of gets the point across here. And that's really what we're looking for here, just kind of getting the point across. But we end up with that negative in front of it. So this right here, if I'm looking to verify, it got close. Since they're not the same, we'd say then that it is not the same, so not identities. I'll be honest, didn't mean to do that on so yeah, that's okay. That gives us a little something to talk about. Most of these that you guys will get, they will all work out. We just got one here that just came up a little bit of a negative short. It happens. No harm, no foul. But let's go ahead and keep going here, friends. Let's go ahead and keep going here. And we're going to go to our notes. We're going to continue on this way. And the first part, what we're going to do here is we're going to start adding a couple of these now that deal with our complementary identities. So let's remember what those complementary identities were. First of all, we had sine of pi over 2 minus x, or minus theta. And we dealt with these back when we looked at complementary angles in trig. This equals cosine. And furthermore, we could go here and say cosine of pi over 2 minus theta. That equaled sine. And so we said, okay, we had all these complementary identities that we had before. So we're just going to go ahead and bring them all back. Oopsies, didn't want that. There we are. We're going to bring them all back here. And we're going to see how we can use them in trig proofs as well. So again, you guys have these on your formula sheet, just so we have them here in our notes while we go through and do these first two proofs. I'm going to write them up here just really, really quickly. Not the color I wanted. That's better. Tangent of pi over 2 minus theta. So these are all our complementary relationships, our complementary identities. And we dealt with this a lot back when we were doing evaluating trig, because these popped up quite a bit there. So let's see if we can't go through here and do some of this that involves some of our complementaries. So let's take our first one. We have tangent of pi over 2 minus x secant x equals cosecant x. So we look and say, okay, well, what is tangent pi over 2 minus x equal to? And you guys will come back and say that is equal to cotangent of x. So we're going to make a real quick trig substitution. Now I got a cotangent and a secant and a cosecant. I got all kinds of weird things going on. So as soon as that happens, I kind of go to the old trustworthy of when in doubt, turn into sine and cosine, friends. So cotangent is the same thing as cotangent, cosine over sine. And secant is 1 over cosine. So I do my trig identities here. And then I notice, oh, these go away. Whoop, whoop. So I end up with 1 over sine x, which is equal to cosecant x. So one final little trig substitution here and get my cosecant x in there. So this one had really, honestly, very, very little algebra. This one was pretty much just one trig identity after another. All right, I want you guys to go ahead and try this next one then to see what you guys come up with here. So cotangent squared of pi over 2 minus x plus 1 equals secant squared x. Well, sometimes, friends, it helps. You don't have to do this, but sometimes it helps. If you need to see a square, there is the, sometimes it helps to look at it in terms of its alternative form to write it, where you basically put the whole thing you just move that x out to the other side, outside of your parentheses. Sometimes that helps. Next year in calculus, when we're doing a derivative called a chain rule, well, it helps sometimes to do that there. But we're not there, obviously, and we're just staying here. So cotangent of pi over 2, that's the same thing as tangent. So what we're really looking here is, this is really tangent squared x. So we do our trig substitution there. And friends, this right here, this isn't too bad at all, because this is one of our Pythagorean identities. If I could actually write it correctly. Tangent squared x plus 1 equals secant squared x. So, and again, that's what we looked at our Pythagorean identities yesterday. We learned them all. So I'm just going to be able to make a straight substitution in here. And I am golden. And we are done. That's a nice simple proof. I like the simple ones. I like the short ones. Those are fun. All right, well, we did those. Let's move on to the last little thing we're going to look at. We also looked at back in when we first started dealing with our trig, we looked at even and odd functions. Okay, we said that some trig functions are even and some are odd. And just as a reminder, again, even, those are functions that are f of x equals f of negative x. Odd is when f of negative x equals negative f of x. So when I'm plugging all these in here, our even function for trig was cosine, and therefore also is secant. Those were our even trig functions. Again, we learned about these again back in Unit 4A. So we already kind of talked about these a little bit here. Just a real quick reminder on them. And our odd functions, well, that was sine. And if it's sine, that means it's also going to be cosecant. On top of that, we also had tangent, which is also going to be odd. That was like the ugliest cotangent there, wasn't it? We can do better. We can do better, friends. All right. So what we're looking at here on these is we're just going to take our even and odd functions now and use them as well to simplify some proofs. So here we go. Let's write this one out here. Cosecant of negative x, secant of negative x equals negative cotangent of x. So I see that I'm dealing with some even and odd functions, so I'm going to go ahead and make my trig substitution. So cosecant of negative x, that's equal to negative cosecant of x. And then secant of negative x is equal to secant of x. So we go through there real quickly and we kind of figure some things out here. And then from there, friends, I'm going to do a couple more little trig substitutions here. So cosecant, that's the same thing as 1 over sine. I'm going to plug that in here. So 1 over negative sine. And now we'll leave that as, we'll make that 1 to negative. And secant is 1 over cosine. So multiply this one over here by sine x and cosine x. As long as I do the same thing to both, I am golden, because that'll allow me to cancel out my common denominator. I gotta do that to the bottom down here. All right, let's see here. The sines go away here. Over here, the cosines go away. And that leaves me with -1 times cosine, so negative cosine. And over here I have sine. I'm not really sure why I started putting all my angles, all my x's in parentheses, but apparently I did along the way. Whatever. And friends, that would be negative cotangent x equals cotangent x. All righty. Let's have you guys try that last one real quick. So go ahead and pause the video and see if you can't give it a try, and then we'll come back and then we'll take a look at it. All right, let's see how we do here. So we got, oops. I don't want to erase all those. Let's just do this. I haven't brought out Magic Eraser here in a while. It's fabulous. So we have cosine of negative theta. 1 plus sine of negative theta. Equals secant theta plus tangent theta. All right. So cosine of negative theta, that's an even function. Make my trig substitution there. And then I got 1 plus sine of negative theta. Well, that's an odd one. So I'll make a trig substitution for the odd. So negative sine of theta. So again, I got something that just, it doesn't look terribly pretty to begin with. So I want to try to do something to see if I can't get some of this stuff to go away. So I'm going to just change its form. So in this case, I'm going to multiply top and bottom by the conjugate, because again, just need to change up sometimes what it looks like. If I would do that, when I multiply it all the way out here, I have cosine theta. I'm not going to multiply this cosine theta in until I absolutely have to. And we talked about that before. Sometimes when if you start doing too much, kind of get yourself kind of caught in a bind. And 1 minus theta times 1 plus theta. So again, difference of squares. So I'm going to multiply that and I get 1 minus sine squared theta. Never want to neglect anytime we see ourselves with some Pythagorean identities here. So let's go ahead and deal with this sine squared now. Sine squared plus cosine squared equals 1. So if we get the cosine squared by itself, that's equal to 1 minus sine squared theta. So again, real quick trig identity here. I'm going to plug that in here. So that was cosine squared theta and kind of see how this is going to play out now. Well, this is a little bit of a longer proof. So cosine goes away. It takes care of 1 down there as well. So I have 1 plus sine theta over cosine theta. Oh, I can see where this is starting to go now. Sometimes, friends, you're just kind of playing with it here. You're trying to just try some different things. Hopefully you can get things to fall out. You know what it's supposed to look like on the right-hand side or the left-hand side. You know they have to match unless I write a problem wrong, which apparently I did earlier. Although it's good to see that too. It's good to see that people are human. I'm telling you, friends, we become a world that's more graceful and compassionate towards each other. A lot of our issues would just go away. And then we can just enjoy each other. Love it. Start being more loving towards each other. How do we get there from trig proofs? All right, we keep going, friends. So 1 plus cosine theta. Again, another quick little trig identity there. 1 plus cosine theta, that's secant theta. Plus sine theta over cosine theta. Well, that would be tangent theta. And we can see all of a sudden they ended up becoming the same thing. And let's end it up. Maybe. There we go. All right, friends. So takes care of our second day of trig proofs. All right, we're gonna spend one more day on this tomorrow. So I'll see you in the class tomorrow, and then we'll have one more thing of notes tomorrow night on trig proofs. Just to get more practice at it. We have all the identities down. We just need to practice doing the verifying and just getting better at it. So I'll see you in the morning, and we'll talk more about this. Take care.